Alright, so let's express x cubed minus 10x squared plus 26x plus 3 divided by x plus 3 x minus 1 cubed as a partial fraction. As you can see here, we have a combination of a linear factor and a repeated factor here. Alright, so I'm going to write this as a divided by x plus 3, and now because we have this repeated factor here, I'm going to write that as b divided by x minus 1 the first time, c divided by x minus 1 squared, and then d divided by x minus 1 cubed. Alright, so these are four coefficients of four partial fractions, and if you expand this denominator here, I'll actually get a polynomial of degree 4, so the coefficients match perfectly. Alright, so let's go ahead and do this. So I have x cubed minus 10x squared plus 26x plus 3. All this I divide by x plus 3, x minus 1 cubed. This is equivalent to, so let's try to see what the LCM of the denominator here is. So that's going to be, that's x plus 3 and then x minus 1 cubed. So if I divide this with this, I have a into x minus 1 cubed plus b into x plus 3 x minus 1 squared plus c into x plus 3 x minus 1, alright, then plus d into x plus 3. So as you can see, the denominators cancel, so I have only the numerators, x cubed minus 10x squared, plus 26x plus 3. This is equivalent to a into x minus 1 cubed plus b into, so I just write that b clearly, right? So b into x plus 3 x minus 1 squared plus c into x plus 3 x minus 1 plus d into x plus 3. So let's begin choosing specific values of x that we think are going to be good for this example. So think about what values you would choose, right? Let me get this color. Okay, so I'm going to put the value of x equals, let's begin with x equals 1, because that's going to help us to kill off this and this and this. That's going to do us really good. And if you do that, you'll actually get 20 on the right hand side. If you just put in 1 here, 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 and here, so you'll get 20 equals 4d. If I put 1 here, that's 1 plus 3, that's 4d. So I actually get the value of d as 5. That's a nice one. Let's choose another value of x. Negative 3 is also good because it will help us eliminate many of these. See, all this will go if we put in negative 3. So if I put in negative 3, right, so I'll get negative 192. I'm using my little calculator here. Negative 192 equals, okay, on the other side you'll have 64f. So you'll actually get the value of a as positive 3. Alright, so what other values of x should we put? Of course, there is no other value of x that is going to give us a 0 coefficient term here, but let's just choose now just simpler values of x like 0. If I put here 0, 0, 0, I'll only have 3 equals, right? What do we have on this side? I'll have a plus 3b, right? So if I put here 0, that's oops, just a moment. If I put here 0, I guess that's negative a. That's negative 1 cubed, it's negative a. If I put here 0, that's 3 times negative 1 squared, so that's a 3, right? Plus c into, right, if I put here negative, 0, that's a 3, and a negative 1, so that's minus 3c. Alright, Yeah, let's go ahead. If I put here 0, that's going to be 3d. Okay, so I already have the value of d and the value of a, so I'll put them there. The value of a is 3, so I'll have negative 3 here. Is that right? Yeah, negative 3 plus 3b minus 3c plus 3d, which is actually going to be 15. So negative 3 plus 15, that's positive 12. Just bring the positive 12 here, that gives me negative 9, equals, I have 3b minus 3c, or 3b minus 3c. Can just divide through by 3, so I'll have negative 3 equals b minus c. Or I could just write this as, just create more space here, I could just write this as c minus b equals 3. So I'll keep this equation here, I'll come back to it. So let me keep this equation here. Let's choose another value of x. So just choose another value here. Let's put x equals, let's choose x equals 2. That's another simpler value. So if I choose x equals 2, we have 8 minus 40 plus 52, if I put here, plus 3. This equals a into, okay, let's put 2 here. So that's 1 cubed plus b into 5 into 1 plus c into 3 into 1 plus d into 5. All right, so we have 23 equals, okay, so what do we have here? A plus 5b plus 3c plus 5d. Now of course I know the values of, I know the value of a, and I know the value, how many values do I know? Right, so I actually know the value of a only. Okay, so let's proceed with that. I know the value of a and the value of d. All right, so I know 2 values. Okay, so I'm going to put those values in here. Let's see what we get. So I have 23 equals, so I put in the value of a, that's a 3. Is it 3? Negative 3. That's negative 3 plus 5b. I don't know what b is, plus 3c. Oops, 3c plus the value of d is 5, so this is a 25. Negative 3 plus 25, that's 22. Bring that here, I'll just get a 1 equals 5b plus 3c. So I have another equation here. So if we just solve this equation and this equation, these 2 equations here, you'll actually get the value of c as 2, and you get the value of b as, let's just try to do that. Okay, all right, so you'll get the value of b as negative 1. So we have all the values. I can now go back up and write this as a partial fraction. So I'll just write for you the values here, just for you to see. So the value of a, right, the value of a, what did we get? The value of a is 3. The value of b is negative 1. The value of c is 2, and the value of d is 5. So the whole of this is the same as a, which is 3 over x plus 3 plus b. For that I'll write minus 1 over x minus 1 plus c, which is actually a 2 over x minus 1 squared plus d, which is 5 over x minus 1 to the power 3. Alright, so that's our partial fraction. So thanks for watching this video. In the next series, in the next part, we'll look at fractions which are actually improper, and we see how to express them as partial fractions. Don't forget to subscribe to the channel for more interesting stuff. I also have more full courses that you've got to check out. So I'll see you in my next video.